Hello, everyone. Welcome to today's webinar. My name is Khalil Doheny, and I'm the Director of Content Marketing at Digital Niche Agency. Today, we have Charles from Atombeam. Charles, how are you doing today?
Good, Cleo. How are you doing?
Awesome, doing awesome. And it looks like we're having, a huge group coming in. Charles, while, we have the audience coming in, do you want to kind of introduce your guests that we have here today?
Sure. Actually, why don't I start the slides because then everybody gets a chance. I'm sort of waiting. Well, I can see the meter ticking there and a lot of folks showing up,
Yeah.
but that's why I'm sort of dragging this out just a little bit. Okay, blah, blah, blah. All right, here we go. All right, so I will share my screen here and we'll get a little bit going here. So just to be clear what today's topic is first is we're going to be talking about how all three of our products fit together. As I think lots of you folks who are coming and participating here know, we have three different things. I mean, one is actually a commercial product and it's in pilots now and so forth. But we will be, I hope, next year releasing the other two. Hope, remember, is not necessarily, but it's looking pretty decent for the progress we're making. So anyway, so with that, I think probably most folks know me already. I'm the CEO of Atombeam, and I was Navy intelligence officer and worked on Wall Street, and so those are actually useful backgrounds for what we do here. Although and I have been CEO of a tech company before, which is actually helpful to actually know something as opposed to not that much, which is very common. So anyway, so with that, let me introduce Josh. I think a lot of you know him from past webinars, but Josh, if you want to introduce yourself, because a lot of new folks probably here.
Sure, Chief Scientific Officer, and like it says, mathematician and computer scientist. So I'm a mathematics professor at University of South Carolina, PhD from San Diego. And yeah, I've been involved with industry for my whole career, and I've been with Atombeam almost since the beginning, 7 years or so.
Right. Now, and Josh, everybody knows here, he was the guy who said, holy smokes, and this is real, this is new, and was the guy who took an idea and turned it into a thing that actually works, which was really awesome. And so, yeah, he came aboard just a few months after we started the company. So, JC.
Hi, I'm Jesse, and I'm managing the sales engineering, solution engineering in Atombeam. I have a pretty long industry experience across the multiple industries, from the oil and gas, telecom, networking, big data, and to some degree AIs. So with the job of the solution engineering, our focus is to take the Atombeam technologies to address the customers' pain points.
Right. And yeah, and so what that really means is he actually makes it work. So in a customer site, really, because, when you're first getting things going, it's not like you flip a switch and everything's fine. As you'll see, it's a little more complicated. But the idea is that JC figures out, okay, that's not working, or this needs to be reconfigured or whatever. And he does that. And then everything works. And the great thing about JC is it works before the customer shows up rather than, we're pretty sure this is going to work, that JC doesn't start with that, which is, he's gold. So anyway, so my idea here is I'm going to give a quick update on what's going on with the company, and then we're going to roll into the technical part. So I'm going to talk about this, and then JC is going to walk us through what's going on with these pilots. And then I will turn it over to Josh, and Josh is going to talk about the tech. So first of all, on sort of customers and partners. So Viasat, they're excited about it, and it's going super well. A few glitches, but they weren't our problem. They, resulted from things and the guys doing the connections. So Viasat's pretty happy about this, and they're already saying, okay, you got to talk to these guys, you got to talk to those guys. In that company that we're doing it with, this pilot wants to talk about a rollout. And so we're going to start talking that next week. Ericsson's working with us, and we expect to be cranking up some pilots with them. There's others too. There's a bunch of them, including one from one of our investors here who's with a big oil company, Oklahoma, which is pretty cool. So second thing is our raise here. It is kicking butt. It's maybe the fastest, but it's certainly one of the fastest raises ever. We're rated in King's Crowd as the highest rated company in doing a Reg A. It's ever raised money in a Reg A. Which is this rating agency for crowdfunding. We have over 4 million in the bank, including the money that StartEngine has. And we have a bunch of big investors, small, medium investors, and bigger ones who are all looking around and talking to us and so forth. So on capital wise, we're doing really well. Another thing is on the team. So one of the things that's really cool about what we're doing is we have a lot of folks here who are really excited about what we're doing. They can see it. They can understand its implications. They want to be part of it. So we're attracting some really strong forces. One of the things we've done is like say, okay, we're not taking venture, at least at this point. We need to have really experienced people who know what the heck they're doing. And so we have a group here that are very top quality people involved in this thing, and we keep attracting more of them. We have our pick of the litter, and it's not candidates, and that stupid picture, all right, whatever. People see us as they understand this could be revolutionary. They want to be a part of it. That's a big attractor for a lot of people in tech is they want to be part of the big new thing, and they see this as potentially that. And in terms of the products, so Neurpac, we all know is, out there right now. It's commercial product. We're working on a bunch of features and so forth, and other optimization things. Neurcom, I should have put those first, but anyway, Neurcom is, the Air Force Research Lab is saying they'd like to see us in a phase 3, and they are going to look to having money for it in fiscal year 26, which starts in October. So we'll see. That's not a guarantee, but that's what they're saying. And the LCM, we are accelerating the development there. The prototyping is really fast. And I think and hope that you'll be able to see something pretty cool come Q4. I don't know when exactly in Q4, they're talking earlier, but we'll see. But Q4, pretty safe bet. And as always, we keep banging out these patents. I mean, one after another, 62 issued and allowed right now, and another 63 that are sitting there being reviewed. So it is a formidable portfolio now. I think anybody would, have a hard time disagreeing. So with that, I'm going to turn it over to JC, who's going to talk about how this works with this trial, with this pilot. So go ahead, JC, and he promises not to get too technical. So.
Well, thank you, Charles. As what Charles described, I'm always the first guinea pig of the technologies.
Right.
So whatever we said, and I don't know whether guinea pig enjoy what they do, but I do enjoy the technologies that we have. So this is the very first trial we have. And in this particular trial, we team up with Sept, as what Charles has mentioned. What the customer's pain point is, as everybody knows, the oil and gas is the very first big data industries. They collect a lot of data with the fracking and also the oil field operations. They're collecting even more data, and the data just keep coming in. The problem that they are facing is, a lot of oil field is out in the remote somewhere, and they have to rely on the satellites to transmitting the data. So the bandwidth is always limited. In addition to that, the cost is high. And so a lot of time they can only transmit in part of the data in real time, not the whole data set. So they kind of limit their operations. And this is exactly the scenario that we have here. Our customers, they collect a lot of data and they cannot send all the data over. So this is where the Atombeam applied the technologies to address their pain points. They are collecting 9 megabytes of data per minute, and 24/7, every minute. And this data has to be sent in a real time. With the Atombeam's compaction technologies, we are able to send all the data. And this trial has been going on for several weeks. Next slide.
Okay.
So this is the real data that we're collecting. This is the 1-day data. And you can see the data roughly around 9 to 10 megabytes a minute. And going through, the resolution of the data is per minute summary. And you can see the blue line is the uncompacted data, the size of uncompacted data per minute. And on the bottom, the red lines is the compacted data. And you can see roughly this is a 1/3 to 1/4 of the compacted data. As a matter of fact, our compaction ratio, which is shown in the middle, the orange lines, this is ranging from 68 to 72% today. Don't be alarmed by the up and down so much. This is just the scaling issue, and the ranges within the 4-5%. A couple of interesting points on this one. And you can see the top lines, blue line, has a little bit up and down. And likewise, the compacted data. On the compaction ratio, you do see the up and down. And if you look at closely, you can see there was somewhat correlate with the data size change. And the reason being is, in this particular case, a customer has a lot of data from the different measurements. And so it depends on what data comes in, in a different period of time, you may see the different data come in more than others. And because of that, they change the ratio of the compactions. And so this is what you see on the data. Overall, they are collecting the 9 to 10 megabytes of data per minute, roughly 13 to 14 gigabytes a day, and about 400 gigabytes per month. So that's quite a lot of data. And this data has been sent into the data centers, just as what they collected on the field. Next. This is the second trial that we have, and this is in the early stage trial. This is the solar farm data. And this solar farm, I'm sorry, let me rephrase what I said. This is a solar farm management data. And this data being collected, to manage the solar farm. And interestingly, you can see the data may be going up and down, but the data characteristics stays quite the same. So we can see the compaction ratio stays around 80%. And
right. Just a quick point, just because to mention this too, is that so the yellow line is the percentage of compaction, and the blue line is the amount of data that they're actually sending, and the red line is the compacted Neurpac encoded data. I don't remember if you mentioned that, but I just want to make sure everybody knows.
Okay, thank you. So you can see the yellow line stays pretty stable around 80%. And that's because of the data characteristics. And that's the other thing, we are very focused on the data characteristics. We are not so much focusing on the physical meaning of the data, because that can, touch the business confidential issues, right? So we are very focused on the data characteristic, focusing on how we can compact the data to the maximum that can provide the best solution for our customers. Next one. So the last one here, this one is the IoT world. And as IoT, the data comes in could be very choppy and with a variety of the protocols associated with that. And in this particular case, our customers is taking in with the so-called spark plug data. And the spark plug is on the MQTT, a level above the MQTT, is sending the data in the binary and also involved in the protocol bus. And so with that, the data can be transmitted through with the well control of IoT data. And because this is the binary, the data is a lot more compact than the regular text-based protocols. And you can see the compaction ratio is roughly around 60%. But even with the binary, we still get a pretty good compaction ratios. By the way, the 60% of a compaction means 100 bytes of the data reduced to 40 bytes. If it's 80%, it will reduce to 20 bytes.
Right. And so why don't you walk them through that thing on the bottom?
So with the data, the red line is the compacted data.
No, I mean down in here.
Okay, understood. Okay.
Right.
And the blue line is the uncompacted data. So based on the data that we collect, and our software will give you the projection, how much is a day, and what you can expect, and how much you can, expect for a month. And with the compaction ratio on the last button here, on the last column here, this is how much you can save compared with the, sending the data without the compactions. So this is give you the idea, how much data that you can save. That can even translate into from the financial standpoint. And this in the next generation of a software that we can translate into the financial impact on your business.
Right. That's cool. That's a really good point, JC, because that's something that I really wanted for a long time, but we really weren't in a position to do. If you are, we have this site you can go to, you can upload your data sample, and we'll come back and say, all right, here's how much you're going to save. Here's what code book you're going to use, blah, blah, blah. And we'll also tell you on the basis of okay, I'm going to send the data over this satellite or however, that you're going to save this much, in terms of the cost of the data transmission. And especially when you're talking satellite, that can be a very considerable number. A Fortune 50 company told me the other day they send 10% of their data over satellites, but it's 90% of the cost of data transmission that they spend. So it gives you a sense. It's a big deal. Anyway,
One thing I'd like to add to the conversation here is our software right now is just the SaaS base. And with the SaaS, we have a real flexible way to connecting to your data source. For example, like your data source is MQTT, we can directly subscribe to your MQTT and process data, compact the data. When we deliver to your destinations, it will be the same form as MQTT as what you see in the original data. So the flexibility of the SaaS our software has is easily adapt to your environments and also transparent, none or very little impact on your business operations.
Great, thanks. Okay, JC, appreciate all that. We're going to move now to Josh, who's going to talk us through some stuff on the tech and how everything sort of fits together. So go ahead, Josh.
Yeah, thanks. So, the big paradigm is of data densification. All of our technologies are in one way or another taking advantage of the fact that there's redundancy in data, the way that it's used today, and therefore there's room to densify it, to make it so that the amount of information per bit goes up. This can help with all kinds of applications and can enable new technologies and features in addition to providing savings, whether it's power savings or bandwidth savings, et cetera. So yeah, if you've got a variety of different data types, so you see images, multimedia, audio, et cetera, well, you could just store them in a data lake, but it's better to store them in densified form because, well, it takes up less room and less power, et cetera. This means needing fewer resources to process it. And it means that it's literally an enabler of technologies like LLMs. The idea is that these modern machine learning models are ingesting some kind of representation of data, And it's really sparse, actually. So it's the amount of information per bit is pretty low, which is one of the reasons that these neural networks are so big and require so much power, so much horsepower, and so much literal electricity to run. So we can help with all that. That Atombeam densifies the data so that it requires fewer connections, fewer nodes, and less processing time to carry out the same operations, or conversely, make room for additional features and additional power. So, the big problem that this is solving is that our pipes are thin, right? We've got limited bandwidth in essentially every context, but it's really inadequate for a lot of users. And there are a lot of workers in particular who could benefit from having additional data at their fingertips. Whether it's to pick on some of the images here, it's a miner who has access to data about the locations of their equipment. Certainly would be useful for them to have immediate access to that. Or, a firefighter to have augmented reality display that they're able to access while they're working in order to be safer and more effective. Or your oil worker and access to monitoring software and the readouts from sensors. These are all things that there's so many circumstances where the user would like to have the data, but it's just the bandwidth constraints are just too much. So we can open up those pipes and get more of the data through in order to enable all of these technologies downstream. Just as one important illustration of that, IoT devices, they are proliferating in a way that's hard to even grasp. So you can see that everything else is sort of leveling off in a lot of ways. These are heavy computing equipment. You can only run so many mainframes and gateways and servers in a data center, but IoT devices are just, they require so little to deploy by design that they're just proliferating in a way that is taking over the world. But this means, of course, that the data that they are ingesting and sending out is also proliferating in a way that is burning up our pipes and just clogging up routers everywhere. So the idea is that if we can help with IoT devices in particular, which, as it turns out, is a really ideal use case for Atombeam technologies, then we can impact productivity across sectors and industries. Yeah, so not hard to imagine all the different circumstances where monitoring, sensoring, awareness, schematics, et cetera, would be useful to a worker trying to get their job done. And just thinking back on the history of computing, we've really been focused on making machines faster and having more processors available. The problems that people were solving in the 50s and the 70s and the 90s, very different than the problems we face today. These bandwidth constraints are really becoming a problem. And well, that's where Atombeam comes in. So we are attacking the problem of information density. That is, we're taking these streams of density of data that's really rather sparse and densifying it so that we're making the most use of each bit in order to represent the information that's being carried in the data. Just to make it concrete, here's a human-readable, time-stamped sensor readout from, I guess, some pool monitor or something of the sort. Of course, you can read this, a little bit messy, but there's a temperature there and a humidity, et cetera. When this is actually stored in a computer, the way that it's always been done, it's stored in ASCII or some representation, you get this sort of middle chunk of data. It's zeros and ones, and of course, it doesn't mean anything to us as mere mortals. It's a lot, though, right? So compared to the original sequence of letters and a few numbers mixed in there, there's a lot because it's very sparse. We've got sparse representations that underlie the way that data is actually presenting to the computer the things that we see with our eyes. And now the idea is to take that and re-densify it. So at the bottom, you see an information dense, but still computer readable representation of the original data. So this is taking that original data and turning it into a stream which uses many fewer bits than the sort of bare bones representation that comes with every operating system on the planet. And just to talk a little bit about how this is done. right? So if you've got IoT data, there's often a header and a payload associated to it. The payload is the data, the header is saying what it is, how it's represented. And the idea is we're going to chop up our data, that payload, into patterns, and then we're going to look for patterns in the payload. And then those are converted via a code book to shorter code words. So these patterns, the idea is that not every string can occur, not every pattern happens in data, and furthermore, patterns often recur. No need to use lots of bits for a pattern that's occurring all the time because, well, you might as well abbreviate it with a very short code word, and that's kind of the name of the game. If you do this for every kind of pattern, you can really shrink the data. That's exactly what in the data that JC was showing earlier, that's exactly what's happened. So there's some incoming data from sensors or whatever kind of device, and it's being replaced with abbreviations that are coming from a code book, makes the data shorter. In those various cases, it was something like 80% shorter, or 60% shorter, 75% shorter. And so, yeah, if you're getting the data 75% shorter, that means you're quadrupling the effective bandwidth. You can get a lot higher data rate, 4 times the data rate, through your pipes because the data is just 4 times shorter. So, yeah, what we're doing is we're cutting up that payload into what we call source blocks, and then they're converted via codebook into code words, which are these replacing the patterns, and then the encoded message is what's actually sent. And because it's only 25% of the original size, this is eating up only a quarter of the bandwidth. That means 4 times as much data can be pushed through the same pipe. To be clear, the compaction ratio varies from data to data type. So it's not always 75%, but that's pretty typical of what we see across all kinds of different data types. And just to talk a little bit about another issue that comes up often, we're talking to customers or potential users. They ask, what about encryption? Because at the moment, there's a big problem in the world, which is that almost all, I mean, really a vast majority of data that's being generated in IoT context, for example, is unencrypted. It's unprotected, flying around in a way that an eavesdropper could just read it or could just make up their own data and inject it into a system. There's all kinds of vulnerabilities that come from the data being just sent as is. It comes out of the sensor and you just send it off. Well, if you use Neurpac, Atombeam compaction, in its the sort of vanilla form, you get some kind of obfuscation of the data. This use of code words to replace the original data means that the data has been obscured in a way that makes it hard for a user who doesn't have access to the codebook to read. In fact, that there's quite a computational hurdle that they'd have to overcome in order to figure out any of the information in the stream. But if you want something that's provable encryption, so not just providing a barrier, providing a hardness that means a casual eavesdropper can't get anywhere, but something that is on par with the kinds of guarantees you get in standard encryption protocols, well, we've got an answer for that. So Neurpac Plus is a marriage of encryption and data reduction. This stems from the observation that data reduction, whether we're talking about compaction or older technologies, compression, et cetera, the game there is to reduce the data to something that looks like noise. Because if you haven't reduced it to noise yet, there's more work to be done. You could reduce it even further because there's patterns. So that's data reduction. You're trying to reduce the data reversibly to noise. That's also the goal for encryption. Encryption is also trying to turn your data into something that's indistinguishable from noise so that no information can be extracted from it. But nonetheless, it's reversible because, of course, it needs to be decrypted at the other end. Well, the idea is you can actually do these at the same time. So when we apply Neurpac Plus, it's encrypting as it's compacting the data. And it actually provides a really strong, provable, mathematically rigorous proof, provable cryptographic guarantees. And in some cases, there are some use cases where it's actually as strong as the gold standard of encryption, which is a one-time pad, which is stronger than all of the encryption that protects our banking passwords and all the data that's flying around the internet. So you can get that kind of strength of encryption from the protocol. it also, of course, at the same time, as the whole point, reduces the data. And in fact, it reduces the data by an amount that's similar to what you get from just vanilla Neurpac. So the data is reduced 4 times very typically. Maybe there's a 5 or 10% reduction in the effectiveness of compaction because of the additional encryption, but it's essentially the same across different data types. We're seeing very similar numbers for the data reduction. And then on top of that, we're currently looking at how to build out this feature or set of features. The data is searchable and accessible in its compacted and encrypted form. So you can store all your data in that giant data lake in a way that, okay, it's encrypted, it's compacted, it's 4 times smaller than you started with, but it's actually searchable. So you can go find a timestamp for the log file you're interested in or the sensor at a particular location and then read it without having to unpack the whole thing. This is a notorious problem with older data reduction technologies. You have to decompress the entire thing in order to search it. It's unsearchable in situ. But with Atombeam compacted data, you can search it and access it and read it at rest, in place, even after the compaction has been applied. So, you might wonder, why can't you search or read compressed files without, like I said, decompressing them? Well, there's this kind of abbreviation process that looks very different that happens with classical compression. Essentially, what happens is that the compression engine searches through the original file, looking for repeats of patterns in the data. And then there's a couple of different ways this can happen. There's sort of 2 examples here. But very often what occurs is that there's a dictionary that's baked into the compressed file that tells you this pattern is represented with this string and this pattern is represented with this string. And then in the data itself, the patterns are then replaced with these shorter strings. So there's all these references to earlier occurrences of data. There's this additional overhead of having to carry around a dictionary that's been prepended to the compressed file. It makes it so that if you try to read the data from any point, it's referencing information all over the compressed file, which makes it so that it's simply not locally readable. You have to decompress the entire thing in order to read it. The way this is often handled in practice is that you chunk your data into gigabyte chunks at a time, and then, or something of the sort, and then it's compressed. And the idea is you then have an index that tells you what's in each of the chunks, so that when you go looking for it, you find the right chunk and then you decompress the whole thing. It's really laborious process, time consuming, energy consuming, et cetera. It means that you simply can't search your data without building enormous indexes in advance and having to cart them around for any applications. To contrast that with Neurpac, we are, like I said, replacing each little pattern in the data with, on average, a much shorter pattern. So, just for a couple of examples here, what this means is you can jump in at any point in the file and start reading. You get true random access and relatedly true searchability as well, because you can search for a given sequence of patterns or of code words because they represent some real patterns from the original data. So it's readable at rest in its compacted form, and it's also searchable in that form, in sharp contrast to classical compression.
Talk a little about what this implies for the giant data lakes that are out there.
It means having to buy fewer platters. It means having to do less maintenance on your data warehouse. It means less time to access. There's all these situations where users got just enormous lakes full of log files that they almost don't look at any of it. But if you go looking for some data, you're going to have to search it. You have to build an index in advance and then search the index for a timestamp, and then go looking among your compressed files for the file that contains the data you're looking for that has that timestamp. And then you have to decompress the whole thing and then find the piece you were looking for. And okay, now you've got it. It's really a time-consuming and energy-consuming process that means that often users are just literally driving the platters around from location to location because it's so difficult to access these data lakes the way that it's handled today.
So like 70-80% of the time analysts spend doing their work is spent finding the data and then cleaning it up. And so, you think about that. I mean, that just means that the amount of cost, the amount of trouble, how long it takes, all that stuff to find the file that you're looking for is enormous. I mean, the implications here for like literally every data center on the planet are big for what this can be. And if you add to that, that it can all be encrypted while it's in storage also, then, you kind of have like what's not the like kind of going on. So anyway.
Yeah, out of the gate, you get all these efficiency savings from not having to go through 70-80% of the process that you would have had to do before.
And you don't have to compress and decompress, which saves power.
Yep. So talk a little bit about Neurcom. So this is another data densification paradigm and set of related technologies. While everything I've been talking about so far is lossless, these are to be used in situations where the user doesn't want a single bit of data flipped from the original. It's critical sensor data or it's critical monitoring software, et cetera. But there are lots of situations that we're all kind of used to where, okay, if there's one bit flip somewhere and a pixel appears a little bit greener than it did in real life, it's okay. It's still perceptually the same to humans and usable in the same way to analysts. So Neurcom is meeting that need by providing data densification that is lossy, but perceptually lossless. And the idea is that in all of the different multimedia settings where you'd like to compress your data, something called a codec is being used. This is what it does. It ingests the raw data. You imagine, a raw image file from a camera or raw video from a video camera live feed. This is passed through a codec in order to reduce its size enormously. So actually all of the images and video and audio that you interact with every day have been passed through a codec that is compressing it. There's, in all of these codecs, in all of these modern codecs, there's a subroutine, sometimes multiple subroutines, that are trying to predict the next bit of data. You can imagine if you were perfectly good at predicting the next frame in a movie, well, then all you'd have to do is store the first frame of the movie and nothing else. You just play it forward by predicting what comes next. So the idea is that the better you are at predicting what happens next in the file of whatever type, whether it's audio or video or an image, the better compression you're going to get. And so there's a subroutine where Neurcom plugs in and does this predictive task better than any other technology out there. We're using deep neural nets that are trained up on representative data to predict the next bit of data. And then this is being used as a subroutine, as a black box that the codec is calling. And the upshot is that you get better compression out of the codec than you could have gotten otherwise, sometimes drastically better.
Which means more images get through, in essence.
Yeah. And actually, I should mention one of the things that we're taking advantage of that classical codecs don't is multiple sources of data. In situations where there are multiple video feeds of the same object, or let's say a LiDAR feed of an object and a visual video of the same object, there's common information between them. If the codec has access to both of them, then you're able to predict better. And so we're able to do exactly that. You've got multiple channels of information that are, where there's overlap between them. You can take advantage of that to get better compression. And just to talk a little bit about our lightweight code word models. Again, the idea is that, these neural networks, machine learning models that are ingesting data, they're ingesting data in a way that the data is presented to them very sparse. You imagine text, it's the underlying representation is ASCII and it's wasting a tremendous amount of bits. All of these different data types have wastage that is eye-watering in some cases. just because of historically how it's represented by computers. The idea is that your neural network is going to be better at its job. It's going to be able to be trained more easily. It's going to, on less data perhaps, it's going to be more efficient, both in terms of energy and in terms of time, if you can present the data to it in a way that's denser. And so that's exactly what we do. We feed Neurpac encoded data or Neurcom encoded data to these machine learning models. And this is you're presenting code words to the model. And then the model is doing what it always does, which is you learn from a representative corpus, and then you try to make predictions based on the incoming data. This can be used for improving fidelity of current machine learning models. It can be used to make room for higher horsepower in a machine learning application. And it can also potentially be used to enable autonomous learning. It is that learning is so burdensome, requires such enormous resources to actually execute, that essentially learning always happens in batches today. So these famous machine learning models that are out there are trained up every few months and then pushed out to the world. What you'd really like to do is do it live, is have the network learn as you go. Well, that's something that might actually be possible if you are able to reduce the resource usage that is required during the learning process as enabled by data densification. And so, yeah, schematically, we're taking neural networks and getting away with a lot fewer nodes, connections, etc., which means fewer cores that have to run it, less energy is needed as an input to run the processors, fewer buses are needed to transmit the data, etc. And in general, you're saving time, power, and of course, money by reducing the requirements to perform the same tasks with machine learning. It's a big headache across the board these days with machine learning, just how much time, power, and money it consumes to actually run the things. And we're able to make a dent in that by densifying the data.
It takes, GPT-4 supposedly took 5-6 months to train it, and something on the order of 100 million. And it's obviously, I'm sure everybody's heard that, it's a big concern about the power, and, the amount of power that AI uses is comparable to, I think, the country of Belgium now, and it's getting more and more all the time. And one of the big things that everyone is trying to do is figure out, how do you cut the amount of power that AI uses? And the other thing about this is the fact that you could make it denser means that you could use a less capable processor, which means that you could potentially put this into an edge device. So Josh, if you want to expand on that a little bit.
Yeah, absolutely. There's a push right now from various directions to try to enable smaller, lighter weight processors with less horsepower behind them to train and to deploy all kinds of machine learning models. There's model compression is one of the ways people are doing this. There's also taking software and burning it into hardware. That's an approach. But Atombeam technology is almost a no-brainer solution to this problem. You can reduce the burden in essentially every respect of running these very heavy models, which means then, yeah, you can use it on a mobile device. There's a lot of AI processing that we'd love to be able to actually run in the phone in your pocket, but isn't done today because it's just too much. It would burn through all the battery power, and in some cases, the processor simply isn't capable of it in a time frame that the user can tolerate. So yeah, this is enabling edge processors, mobile devices, and low power devices all over the world to perform the kinds of heavy duty processing that is happening today in data centers and really powerful servers.
Yeah, one thing I need to say here, just because we are raising money and everything, that this is an early stage project. I don't want to advertise that, yes, this is done, you can count on it and all that stuff. It's early stage, still has a lot to prove. We're, encouraged by where we are and how it's going and all that, but it isn't real until it's real.
Yep, absolutely. And you saw with the data that JC presented earlier, that's deployable today, right? That exists and does exactly what we're describing. Some of these other technologies like
Right.
Neurpac Plus and LCMs are in various stages of development.
Right. This is kind of what you were already kind of addressing here.
Yeah, just sort of comparing, what's the benefit, right? So if you can current generative AI, which is a broader category than just LLMs, the input is it's language, it's text from a file. But the idea is we're going to replace that with code words. You can use less resources to train, to run them. It enables more multimodality, that is natively being able to feed different kinds of data to a machine learning model. And it possibly means being able to train these AIs on the fly instead of having to do it in batches that happen every 6 months. So yeah, just to summarize, we've got a whole new paradigm in thinking about how data is used and processed. It is data as code words. We're representing your data in a highly densified form, taking multimodal data, densifying it into encoded data, which is then stored, processed, and used in all the ways that we use data today, because fundamentally the goal is to have densified data that's still usable the same way that data is today. And then using that to enable new technologies like LCM and all the other AI technologies that are coming down the pipeline.
Right. So, and that is the end of our discussion. I mean, our end of what we've come to present. And so with that, why don't we turn it over to Khalil and ask any questions that have accumulated here, please. Okay.
I don't remember when the 18-month plan started, but based on when it started, how would you say where you are currently and how has your outcome for the end of the 18 months changed?
Sorry, say it one more time. You're a little bit garbled.
Yeah, so I don't remember when the 18-month plan started, but based on when it started.
Yeah. So the 18-month plan was kind of trying to get us to mid next year. And so we're on track for that. It's basically to say we have the goal there was to have Neurpac out selling with some sort of reasonable amount of revenue. We're on track for that. The goal was to get Neurcom to a point at which we could say it's either ready as a product, or at least it's in the process of being productized. And when we set the 18-month goal, the LCM didn't exist. So, all I can say of that is that, incorporating it into the 18-month concept, I'd say the goal is to have something pretty compelling before the end of this year that we can show the world, and to be able to stomp on the accelerator to the extent that we find that we believe there's going to be, as Josh has been expressing, a lot of need for this thing. And but exactly how it gets manifested, because it's still, as I said, an early stage project. So exactly how we monetize it, is less clear. But, there's all sorts of potential avenues, but we have to figure out that. Whereas Neurpac, solid, we know what it does. It's out there right now doing its thing.
And then one company says it has a new GPU that is theoretically equivalent to about 62 NVIDIA H100 GPUs. How will Atombeam relate to that? And will it enhance the performance of such a chip? Or is that something that competes in some way with Atombeam's technology?
That's a Josh question.
Sure, yeah. So that is quite the claim. I'm not familiar with this company, but love to look into that. I think, generally Atombeam's technology is software. So it can provide an additive benefit beyond whatever they're already doing to get those kinds of numbers. And it doesn't interfere with their technology. I have to look at the details, of course, but generally speaking, you can do the same thing but get the benefit both from their technology and from Neurpac.
And then some computer networks will not allow compressed files since these files might contain viruses, etc.
It's interesting. Actually, you can perform live analytics on streaming data that's been compacted because it's locally decodable. You could scan the files as they go through for viruses without having to decompress them, which is a big benefit over standard compression.
Yeah, it's Cerebras is the company that is making that claim. They're basically putting together a bunch of different processors and sort of making it. Their thing was they came up with a way of having the processors communicate with each other. I'll send you the stuff I have on it.
Cool.
All right. Let's see. And then will Atombeam be blocked like compressed files?
It's a pure streaming technology, so it doesn't. You could, of course, package it into blocks, but the way that it works today is it's a pure streaming technology. So turning one stream into a compacted stream.
And then how many companies are piloting Atombeam?
Today, it's just one. But it has a multiplier effect because it's being done through Viasat, and so Viasat has a lot more than one. They wanted to see, okay, let's see this actually work in real life. And because we've shown them before and, over their satellites and so forth, but they want to see it work with a customer in a real world situation and all that. So they are confident that they're now confident in us and that it works and all that. And so in effect, yes, it'll be a lot more. Right now it's one. However, there's a pretty considerable company that would be like a channel partner like Viasat that is also testing it. And that was one of the slides that JC went through, and a number of others. There's no end of companies ready to test it. We need to make sure we don't mess it up. So we're going carefully. We're doing things in order, going too fast and adding too quickly. We don't have that many resources. There's not many JCs around. So we need to do this right. And we need to make sure that everything works and everybody's happy.
And then, Charles, we're going to have to be careful with how we answer this upcoming question. I first invested in Atombeam in 2021 and have been hearing about progress and opportunity for further investments since then. I'm excited for the future, but could I get some idea of a roadmap to liquidity for investors? Thanks.
Right. I think I'm heavily constrained, as you're saying, with that. I can just sort of talk generally and say that most companies like ours get bought, but there are some that hold out, raise more money, get to a point where you got to have more than 100 million of revenue. You got to have multiple hundreds to go public. I mean, you can go public before. We have bankers trying to do it, get us to that now, but it's there's a lot of potential here. And I don't know what the exit is. All I can tell you is our focus, and the thing I tell everybody internally too, think about building value, and think about, medium and short-term and medium goals. Don't worry about the future in terms of the exit yet. It will happen. It'll happen whether we are focused on it or not, but I don't want the focus to be on that. I want the focus on building the value of the company. And that's what everybody does and agrees and so forth. We are making this company more and more valuable every day. And that's what we need to do.
For the oil and gas application, if the company can get more data more quickly, does it think it can better operate the well, get more oil out, get it out quicker?
I think that, well, I would say this, that nobody on this call on our side is an oil and gas guy. And so I don't want to answer that question, try to answer definitively. I can tell you that the view that the oil people that we deal with say is that things like preventative maintenance, knowing when a pressure is low or high on something, knowing when a pump jack's standing up or it's dog-legged or this, that, or, stuff that sensors are detecting, and they can get ahead of a problem, and that'll prevent shutdown. But then there's other things that just sort of help them optimize the amount of oil they're pumping. I mean, what we really need to have here is an oil guy who can tell you in some kind of definitive way. All I'm doing is sort of repeating what I've been told. But the important point here is that, yeah, I mean, as JC mentioned, you save money on how much it costs to transmit the data, but way more significant is to a lot of these guys is they believe that they will have more revenue if they can get more data. And it's what it comes down to. And so if we can facilitate that, they really care about that.
And then what are the current hiring priorities?
So we are, still bringing on more engineers. We are, working on the channel, development right now. So people around that. We're going to have to bring in somebody else in marketing. We have a VP marketing, and she has one person helping her, but we're going to need more on that end of things. So we, I mean, it depends how much money we raise, a lot. We can't jump the burn ahead of the revenue too much, but at the same time, now is our time. We believe that we got to push hard. And that means having enough resources to do it. And so, nobody here is getting rich off of what they get paid. Everybody is like focused on how the value can be built and all that. So all I'm saying is that, Ned, we're doing things around creating the revenue. There is work being done on research and development, but the focus is on the product and on selling the product. That is, say, the Neurpac product that we have right now in the market.
Okay, so I've got just a couple more here. Would companies pay to have their deep data lakes decompressed, then compressed with the Atombeam codebook technology?
They would have to. I mean, we're not going to do it for free, right? But so that's a project for the future. We have to, we haven't released that feature. It's something that works in prototype right now, but that's not a enterprise level product. Has to be tested beyond belief and, absolutely rock solid. Nobody can do anything to mess it up, kind of thing. And so when we have that though, yeah, we will put together. And so I don't want to get ahead of my skis, right? And so thinking about exactly how it would work and so forth. But yeah, the plan would be, okay, do you want access to all your data in the data lake? Yeah, you would probably, be like putting it through some sort of running it through a coffee machine or something. It's like the compressed data goes in, it gets decompressed and then compacted with Neurpac and then pushed back out into the data lake, and you just have the whole hose running, for as long as it takes. But, yeah, I mean, presumably we would, and we haven't got the pricing around that and so forth, but there's no question we'd want to charge people to do that, right? I mean, it's quite a lot of work, and we'd want some kind of ongoing fee for using it in the future.
And then are there any plans to work with academic institutions? It seems like there's a big opportunity to educate industries on the data as a codebook paradigm.
Yeah, I mean, so Josh is an academician, although we're not officially working with University of South Carolina. Neurcom is being developed by a team mostly at the University of Missouri, Kansas City, who has one of the top video compression teams on the planet. I mean, they're really an amazing group. And I've had Professor Zhu Li on before, who leads that group. and we could again. But his group has won prizes for, top guy in the US for, video compression and all this stuff. And stuff he builds is really, it's pretty practical. It's something that can be used in the real life as opposed to something that gets to an academic level of, of high level, but not really usable in a real world application. So we do partner with them. And Josh, we don't have other academic partnerships, right? Or do we? I'm trying to think.
No, nothing formal. We have some employees and consultants who are, coming out of academia, but
Yeah, right. Yeah, absolutely. And then I'm pretty connected with Stanford and their CS guys and so forth. And so I think when we get the LCM a little further, then we'll probably pull them in, but we're waiting until we get a really solid bunch of patents filed before we expose the guts of that to, anybody outside the company. But anyway, so that's the deal. But yeah, I agree. It's definitely what we do is really cutting edge stuff and of interest to academicians, and definitely something that I think, so Josh has written a paper about Neurpac Plus. It's being submitted and it's going to be really, I think, a big deal when it gets out there. Because if you were to say, if you were to design, say, what are all the things I'd like in an encryption? Well, if I had anything I wanted, yeah, it'd be super light. It reduced the size of the data, not make it bigger. And it's stronger than standard encryption. And it still be usable, searchable after it's encoded. Okay, that's about everything. So, okay, it does it. So that's going to make a big stir, we think.
And then where are we with the Reg D?
So we just got a draft from the lawyers yesterday. So presumably we are getting close to getting that knocked out. So, stand by for it. I'm hoping that happens. It has to happen in the next couple of weeks. I got to make it out, got to get it done. So that's the plan.
And then is the overhead for compressing the data taken into consideration when figuring out the speed that the entire process of compression and decompression of the data is a significant amount of time?
Yeah, so actually the technology is designed from the ground up to be time efficient. And so one of our greatest selling points is that extremely low latency. That in a lot of ways, the game is offloading the heavy processing, the slow and energy consuming heavy processing that occurs during things like classical compression to a pre-processing stage. So that's done before any of the live data is being encoded or decoded via the codebook. So that is very low latency. That's actually like a key feature.
On getting Neurpac onto the cloud companies, yeah, that is a natural progression, and we haven't pushed it yet, but it would make a lot of sense. And AWS certainly knows what we're doing and is following along, and they're not stupid. And I think, that's a very real possibility. And recurring revenue yet, no, but, we do have revenue coming from DoD here. Implications of Neurcom for streaming video services, I'll leave to Josh.
Yeah, I think it's exactly the kind of benefits you get from plugging into a codec. Less bandwidth, better data rates, improved fidelity, et cetera.
Okay. Yeah, so we'd be sending presumably more video through the same pipe. And obviously, if you're a telco or whatever, you're going to say, oh, well, that's a pretty good idea. We'd like to hear something about it. That's something they focus a lot on. Now, at the same time, I should mention here, we're not chasing that right now. We want to develop it, nibble at the edges, we don't want to be anybody's crosshairs. We just want to, do the work. It's the same work on things like synthetic aperture radar and hyperspectral images and thermal and stuff like that. And it's also paid for by the Air Force. And so what's not to like, because you're still developing it, does the same technology apply to RGB, to standard video, yeah, sure, why not? But we don't want to like say, okay, we're out there and then everybody starts shooting at us, you know, it's better to avoid that. So the last one is for Josh too. Atombeam technology can be used instead of transcoding or together with it.
Yes, I saw the question posted earlier. We're not using it for transcoding, but I think you actually kind of got my wheels turning by asking that, because I don't see any reason that it couldn't be, because similar kinds of predictive inputs are needed during modern transcoding as occur during just codecs, the way that I was talking about it earlier. So I think there are some possibilities there. Now I'm going to have to think about it.
All right. Yep, that's dangerous. So anyway, thank you, everybody. Thanks for sticking around, all you guys. I appreciate it. And really appreciate all your time and sticking around and listening in. We feel really good about how we're doing, and we appreciate really a lot all the support you guys have given us. We haven't had to go to venture, and I couldn't be happier. And so thank you very much. And you'll continue to see us out there. We'll continue to communicate, ask any question you want. All right. Thanks very much.
Have a good
Thank
one.
you.
All right. Bye.